With the increasing popularity and usage of blockchains, access to reliable and accurate blockchain data has also become more important for developers, users, and investors alike. In this video, we look at some of the most popular ways to access blockchain data and compare what they have to offer in terms of data coverage, API access, and SQL friendliness, among other things. Each method has its own pros and cons, so we'll be talking about what those are, and which would work best for certain users. Now let's get started. DIY, Custom ETL on hosted nodes. First on the list is for those who want to do it yourself. You have the option to self-host a node or spin one up by using services such as QuickNode or Alchemy. From there, most blockchains support clients that can connect to nodes via RPC and return data in JSON format. The best thing about DIY is that you have complete control over your data pipeline, along with having flexibility on what's extracted and how the data is stored. On the downside though, it's quite demanding. DIY ETL requires a lot of work to set up. It's also expensive and takes a lot of time to manage. With that in mind, DIY is perfect for those with resources and prefer the control and flexibility. Dune Analytics. Next up is the OG of crypto data, Dune. Dune is one of the earliest in the blockchain data space and has built a considerable following from crypto data analysts thanks to its user-friendly interface and features. Dune has SQL queryable datasets, an easy-to-follow charting UI, and even social media sharing features. The pros of Dune is that it is SQL friendly, has a free community tier, contains a graphical interface for building charts, and a large community so you can get answers to your questions in a timely manner. On the other hand, Dune has no API and some of its datasets are uncurated. Dune's V1 engine, built on Postgres and where most of its data and queries are, is also relatively slow. If speed isn't critical and analytics is your main use case, then Dune Analytics might be a good option for its simplicity and breadth of data. Nansen. And then we have Nansen, which is described by its CEO as a service that aggregates data on millions of addresses. Nansen has great low-code interfaces, deep data sets on NFTs, and integration of a lot of off-chain data to enrich on-chain data. Nansen also offers pre-computed metrics that can be sliced and diced by analysts. However, Nansen has limited flexibility if your use case requires raw blockchain data or complex joins. Additionally, API access is locked behind an enterprise sales process. Data is also read-only for the majority of plans, and you have to be on a $3,990 per quarter plan for a simple CSV export. TheGraph. In the full ethos of crypto, TheGraph is a decentralized protocol for querying and indexing blockchain data. It allows developers and apps to query blockchain data using GraphQL in a more decentralized fashion without relying on a single company or entity. However, queries are paid for in GRT, the Graph's native token, which can be volatile, and the fully decentralized version currently only supports Ethereum. The learning curve for GraphQL can be steep if you're coming from a data analyst background, plus you'll be getting less support than what you might get from a more centralized service. Bigquery public crypto datasets. We also have Google Bigquery, which has publicly available datasets containing raw data for several popular chains. The data tables are accessible to anyone with a Google Cloud account. It's easy to get started, and has a good performance on large queries thanks to the Bigquery engine. A caveat would be, there is a limited number of chains supported, and no decoded data. It's also unclear if these datasets are being actively maintained, and there is no support if you have questions about the data. Finally, it can be expensive when it comes to large or frequent queries. Luabase. Last on the list is Luabase. Luabase is a SQL and API-first blockchain data warehouse. Luabase offers clean on- and off-chain data in an easily accessible format via both API and SQL. The queries on Luabase are fast thanks to infrastructure built largely around ClickHouse by a team of modern data stack experts. It also attempts to maximize use case flexibility by offering both raw blockchain data and the ability for users to define and save their own metrics. There's a lot of things to like about Luabase. It's SQL-friendly, has a full API, has real-time raw blockchain data, decoded smart contracts enriched with off-chain data, and a query scheduler. It supports custom data imports you can join with any Luabase dataset. The API also supports data export destinations such as S3 and Google Sheets. Luabase currently only supports EVM chains plus Bitcoin and has limited dashboarding capability, though these features are on the near-term roadmap. Conclusion: choosing the right blockchain data provider comes down to use case and technical expertise. Hopefully this video has provided a good review and comparison of popular options.